lecture we have shown how to reduce the number of states for a completely specified machine, that is for a DFA. It has two procedure, one is mark and reduce procedure, another is method of closed partitioning. But here we will show you that how to reduce a number of states in a machine where for a particular input the outputs are not specified. Suppose in case of A, state A, if I give the input I1, then you can see that the outputs are not specified for I1. Similarly, for B, I2, I3 and I4 inputs, the outputs are not specified. It may also happen that in some cases that the outputs are specified, but the state is not specified, or it may happen that the state is specified, but the state is specified, suppose E, and the output is not specified. So, all these cases can be considered as an example of incompletely specified machine, and how we can reduce the machine in case of an incompletely specified machine. Incompletely specified machine is basically a table that is that is formed from an NFA. In case of NFA, for a particular input, the output may be specified or may not be specified, or it may happen that there may be more than one next state and output. So, basically this procedure is applicable for the NFA, how to reduce the number of states in an NFA. And the procedure, there are two procedures are there, and that procedure is called merger graph and merger table procedure. Now, to identify the pair of states which may be reducible, we need to know what is compatible pair and implied pair. Compatible pair and implied pair. So, what is compatible pair? A pair of state Si and Sj is said to be compatible if for all the inputs the outputs must be same. Output must be same. Now, how to identify the output? If some cases the outputs are not specified. So, output must be same means that output may be specified or may not be specified, or may not be specified. Now, if all the outputs are specified, that means output and next states all are specified. Suppose for a particular input Si and Sj, for a particular input I1, the outputs are Sp and Sq, which is specified. Then Si and Sj will be compatible if the outputs are same, as well as the specified output Sp and Sq. These are called implied pair. This implied pair must also have to be compatible. Means, I am repeating again, a pair of state Si and Sj will be compatible if its implied pair Sp and Sq, which is an implied pair. This is my implied pair, must have also to be compatible, and if the outputs are not specified, that case we do not have to check for the implied pair. Now, let us give an example from this table itself. Suppose consider a state, suppose BC. Now, BC, in case of BC, for I1, I2, I3, I4, for I1 the outputs are same 0 0. For I2, one output is specified, another output is not specified. So, that unspecified output we can consider it as a don't care condition, means the output may be 0 or may be 1. For my convenience to make it compatible, we can consider this output as 1. Now, if I take this output as 1, that case for I2 the outputs are same, and for I3 as the outputs are not specified, we can consider it as same, and for I4 also it is same. So, we can say that BC is compatible, but in 3 inputs the outputs are not specified, and for 1 input the output is specified. Now, for that 1 input, that respective the states, that is E and F, will become the implied pair, respective states this will become an implied pair E and F. Now, we have to check that B and C will be compatible if its implied pair E and F is also compatible. Now, check for E and F. Now, in case of E and F, for I 1, one output is not specified, we can consider it as 0. For I 2, another output is not specified, so we can consider it as 0. For I 3, both the outputs are same. For I 4, both the outputs are same. So, we can say that E F, that which is the implied pair, is also compatible. Now, for that E F compatible pair, we have to check. Do you have to check the implied pairs compatibility? Yes, we have to check, but for the time being we will not check it. We will check it whether when we will create the compatibility graph, that will be done later on. Now, the basic concept is, for any pair of states, if the outputs are not specified, that case we can consider this as that B C for that particular pair of state is compatible, and if the output is specified, that case that specified output pair of states will be considered as the implied pair of states, and that implied pair of states we have to check the compatibility for that implied pair of states. Now, after doing this all pair of states, we have to make the graph. That graph is called the merger graph. Let us draw the merger graph. Suppose consider the first state, that is A B. A B. Now, for A B, A and B, we have to check that whether it is compatible or not. Now, for A B, look at this. For I 1, the output, one output is not specified, right. For I 1, one output is not specified, another output B. For B, the output is E 0. Now, for my convenience, I can consider this output as 0. For I 2 also, for A output is specified, that is 1, and for B the output is not specified. So, I can consider this output as 1. For I 3 also, for B, I can, if I consider the output as 1, then the output will be output for the pair of states will be same. Similar case will also be where the output for B we can consider it as 1 and it will remain same. So, we can say that for pair of states A B, all the outputs for the input A I 1, I 2, I 3, I 4 all are same, but as all the outputs are not specified, we can consider that A and B are compatible pair of states, but its outputs are not specified. So, it does not have contains any implied pair. So, we do not have to check the compatibility of the implied pair. So, A B is done. Now, we have to check for A C. AC pair. Now, for AC pair, look at this. For I 1 output is not specified, for I 2 output is specified, that is 1, for I 3 output is not specified, for I 4 output is not specified. So, AC I can say it is compatible. If it is compatible, draw a straight line between them. So, AC is compatible, as well as I cannot say it is provisional compatible. AC will be compatible if its implied pair CF is also compatible. Now, check the compatibility for C and F. Now, in case of CF, for I 1 outputs are same, for I 2 outputs are same, for I 3 outputs are same, and for I 4 also outputs are same. So, I can say that AC is compatible and its implied pair as its implied pair CF is compatible, as at its implied pair CF is compatible. Next, check for AD. Now, AD I 1 output is same, I 2 output is same, I 3 output is specified and output is also same, and I 4 output is same. So, AD will be compatible if its implied pair where the output is specified, that is for I 3, and the next states are EB. So, AD will be compatible if its implied pair EB is compatible. Now, let us check the compatibility for EB. So, for E and B for I1 output is same, I2 output is same, I3 output is same, and I4 output is same. So, we can say that AD is compatible, and its implied pair BE is also compatible. Now, let us check the compatibility for A and E. Now, AE for I1 output is same, I2 output is same, I3 output is specified and it is also same, and I4 output is same. Now, for AE for input I3, the outputs are 1 1 and the next state is BE. Now, we have to check that AE will be compatible if its implied pair BE is compatible or not. Now, let us check the compatibility for BE. Now, for BE the outputs are for I1, I2, I3 and I4 all are same. So, we can say that AE is also compatible. Now, let us check once again. No, AE is not compatible, as for I2 the outputs are different. For I2, look at this, outputs are C1 and F0. So, the outputs are different. So, we do not have to check for the implied pair again. So, AE is outright rejected, that it is not compatible. Now, let us check for AF. Now, for AF, for I1 output is same, for I2 output is same, but for I3 the outputs are 1 and 0. So, AF is not compatible. So, with A we find out AB is compatible, AC is compatible, AD is compatible. AB does not have any implied pair, but AC and AD has implied pair. Okay. Now, let us check for B and its pair. So, for BC, first for BC, for BC I1 output is same, I2 output is same as and also have implied pair, that is FC. No, not for FC, sorry, BC I1 output is same and its implied pair is EF. We have to check the compatibility of this implied pair EF later on. I2 output is same, I3 and I4 outputs are same. Now, let us consider the implied pair EF, whether they are also compatible or not. For EF, all the outputs are same, I1, I2, I3 and I4. So, we can say that BC is compatible, and its implied pair is EF. Now, let us consider for BD. Now, for BD, I1 output is same, I2 output is same, I3 output is same and I4 output is same. So, BD is compatible and it does not contain any implied pair. Now, for BE, I1 outputs are same, I2 outputs are same, I3 outputs are same and I4 outputs are same. So, BE is compatible and its implied pair, it does not have any implied pair. Now, check for BF. For BF, I1 outputs are same and implied pair is EC, I2 output is same, I3 output is same and I4 output is same. Now, let us consider the implied pair, whether it is compatible or not. Now, for EC, outputs are not same in case of I2. So, as the implied pair is not compatible, so the compatible pair that we are checking, the compatibility of BF will also not be compatible. In this case, what we have to do, that we have to draw BF, we have to draw BF and we have to write the implied pair, that is EF you have to draw BF and its implied pair, sorry, CE. CE is not compatible. So, we have to write CE and we have to cut it. Okay. Now, let us check for CD. So, CD I1, I2, I3, I4 all outputs are same, but it does not have any compatible pair, sorry, implied pair. Now, for CE, I1 output is same, I2 output is not same. So, it is outrightly rejected that CE is not compatible. Now, for CF, for CF the outputs are same for I1, I2, I3, I4, as well as it has one implied pair, that is CF. That means, CF has its own implied pair. So, what we have to do, that we have to write CF only, but we do not have to mention the implied pair, because the same state is there. Next is DE. Now, for DE, look at this, for I1, I2 outputs are same, but for I3 output is not same. So, we will reject it. Sorry, our DE will not be compatible, right. As for I3 input, the outputs are different. Now, let us check for DF. So, for DF also the outputs are different for input I3. So, DF will also not be compatible. Now, let us check for EF. For EF, I1, I2 outputs are same, for I3, I4 also outputs are same, but I3 and I4 does have one implied pair, that is AB and CD. Now, AB is already compatible because there is a straight line between A and B, and CD, let us check for CD. CD is also compatible because there is a straight line in between them. So, we can say that EF is compatible as its implied pair AB and CD are compatible. So, you have to draw a straight line between E and F, and we have to write the implied pair in between AB and CD. So, this is the complete merger graph. This is the complete merger graph. Now, based on the merger graph, we can say that what are my compatible pair of states. Now, suppose if I write all the compatible pair of states, that it would be AB, then AC, then AD, then BC, then BD, then BE, CD, CF and EF. So, 1, 2, 3, 4, 5, 6, 7, 8, 9. So, 9 pair we got out of these 6 states. So, if I consider all these 9 pairs as they are compatible, means they will behave like same. So, my number of state will increase instead of reducing the number of states. So, this is not a solution. So, how to reduce it further? For the further reduction, what we have to do, that we have to make one compatibility graph, because we have to find out, actually this is set. Out of this set we have to find out a subset which will be compatible as well as every time for all the pair of inputs it will show the same output, and how to figure it out, that we identify that pair of states which we have to take, that will contain all the properties of equivalence. Now, we have to find out out of this pair of states those pair which maintains the property of minimal closed covering. Minimal closed covering means that out of this set we have to find out a subset that satisfies the properties of minimal closed covering. We will tell you later what do you mean by the minimal closed covering. A pair of state is said to be closed if a pair of state Si and Sj is said to be closed if its implied pair also belong to this subset. That means, out of this pair of set of A B, shall I write this again? It is A B, A C, A D, then B C, B D, B E, C D. So, out of this let us consider any pair, any arbitrary pair. Suppose if I consider any arbitrary pair, that is A B and B C, we have to check that whether A B and its implied pair and B C and its implied pair also belongs to this pair of belongs to this set or not. Now, A B does not have any implied pair, as well as B C does not have any implied pair. So, we can say that this pair is a closed pair. Now, I need to find out that minimal closed covering, right? Minimal closed covering. Now, this pair is closed, but is it covering? Covering means, is it covering all the states that are present in my machine? My machine have A, B, C, D, E, F, 6 states are there. So, it contains only A, B and C, but what about D, E, F? Now, let us include that case D E is not present, right. So, let us include B D, then include E F, then I suppose A, B, C, D, E, F, all the states are present. Now, if I consider this pair of this subset, now A, B and B, C, these are closed, okay, fine. Now, for B D, what about B D? Now, B D has the implied pair, B D does not also have any implied pair, okay, fine. Now, for E F, E F has the implied pair A B and C D, that means A B is present over here, that case we have to include C D also. So, if I include C D, that case I have to check whether what are the implied pair for C D. C D does not have any implied pair. So, we can say this pair A B, B C, B D, C D and E F is a closed as well as covering. It is closed because all the pair and its implied pair are present within this subset, and it is covering all the states. Now, whether it is minimal, we have to consider the minimal pair of states. So, it is very difficult to find out through trial and error method, considering all the states and its implied states, whether it is covering all the states or not. It will take lots of time. So, instead of this, what will you do, that to minimize and finding out the solution in an optimum manner, we will draw one graph that is called compatibility graph. Compatibility graph will help you to identify the closed set of compatibles, and not only closed set of compatibles, when whether they are covering or not. And if I find out all the possible solutions, that case it will be very much easier for me to identify the minimal closed covering values, and that would be my answer. Now, what is compatibility graph? Compatibility graph is very easy. Draw the compatible graph to implied, draw the compatible pair to implied pair, one directed line. So, my pair is AB. Now, from AB, does AB have any implied pair? No. So, put a dot over here. Now, for AC, I have an implied pair CF. So, draw a direct and straight line from AC to CF. Next, AD. Sorry. Now, from AD is a compatible pair and its implied pair is BE. So, I am drawing one directed graph. Now, next compatible pair is BC, and BC has EF. Next is BD. BD does not have any implied pair. Okay, fine. Next BE. BE does not have any implied pair. Fine. Then BF is not compatible. Then CD. CD does not have any implied pair. Then CE is not compatible. CF is compatible, but does not have any implied pair. Then EF. EF has two pair. EF has two implied pair, one is AB, another is CD. Now, try to, as we have drawn based on the compatible pair to implied pair one directed graph. Now, let us try to connect all those pair. As it is a directed, we can easily connect it if it is possible, if it is present. Now, look at this for EF to AB and CD. Now, is there any connection possible from EF to EF? Yes, from to EF there is a connectivity possible. So, let us connecting this one, that means BC to EF, and delete this one. We have connected this. Now, is there any other further connectivity is possible? I think no. This one is AC AD and CF BE. CFB. So, further connection is not it is not possible. So, from this why, what is the meaning of, what is the function of drawing this compatibility graph? So, from this compatibility graph we can easily identify the sets and its the corresponding compatible pair and its implied pair. Let us redraw the same graph again over here. BC to EF and then AB CD. Now, if I consider this set, look at this BC, EF, AB and CD. If I consider all the pairs and its implied pairs are present over there, we can say that this one is closed, because BC and its implied pair is EF, EF and its implied pair is AB and CD, AB and CD does not have any implied pair. So, all pairs and its implied pair all are present in this set. So, it is closed, it is covering A, B, C, D, E, F, all are covering this one, right. Now, is it minimal? So, as for the 6 states are there, minimum 3 pair can be possible, right. So, here 4 pairs are there. So, it can further may be reduced. So, how to reduce it? Look at this, can we remove any one of them? After that also it will become compatible, closed as well as covering also. Look at this, if I reduce BC over here, then it will become only EF. No, if I consider only this portion EF, AB and CD, that case EF, AB and CD, look at this, EF and its implied pairs are AB and CD, and AB and CD does not have any implied pairs. So, it is closed, as well it is covering A, B, C, D, F, all the states are there, and it is minimal also, because less than 3 pair is not possible. So, this should be my optimal answer, which satisfies the properties of minimal closed covering. So, instead of considering these 6 states, I can easily reconstruct this table using this 3 pair. Now, let us draw the minimum table. Now, let us consider AB as alpha, CD as beta and EF as gamma. Now, what will happen if I give I 1 to AB? So, if I give I 1 input to AB, either I can consider A or B. So, if I consider A only, that case it will be dash, then next one is C 1, C is beta. So, it is beta 1, then E is gamma 1 and then B is alpha 1. And for beta is CD, either I can take C or D. So, if I take only C only over here, then first one is F 0 means gamma 0, next one is F 1 that means gamma 1, next ones are dash dash. Next is EF. For E, if I consider only E, then it will be dash, then gamma 0, then alpha 0 and then CD, that is beta 1. So, this should be my reduced minimized states for an incompletely specified machine. Now, we can convert it to respective NFA out of this.